There are great problems in Africa in terms of production problems with poverty, problems with ag development, and the technologies that we develop aren't going to solve everyone's problems because there are lots of challenges to deal with. But clearly there's a need for technology development. I think we play an important role in developing technologies that solve farmer problems, both in terms of forage production and grain production in these two countries in West Africa.
Sorghum is a main staple in many parts in Africa, and my research, which is making that sorghum more nutrient available. Sorghum naturally, when it is cooked, it has its nutrients being trapped that makes it less available to the consumer. So what I work on is to make sure that to improve that availability of the nutrients in the sorghum that is consumed so that the consumer does benefit from it. Malnutrition would be something that we can fight through that process, especially when it is consumed as a staple.
Grain sorghum and forage sorghum, that's one of the key elements of my research program at Purdue. And most of my work focuses on technology development related to developing new traits for those crops, for the forage crop and the grain crop. And over the last 2 decades, I've been developing technologies that address particularly focusing on quality traits. And we've been fortunate to have a chance to develop technologies that improve protein digestibility, starch quality and digestibility, forage quality and digestibility. And we've been developing these traits and using the tools of genomics to address questions about how might this impact a farmer in the United States. And one of the big opportunities that we've had in joining the SMIL team is being able to deploy these technologies to solve farmer production problems in West Africa, working with programs in Senegal and in Niger.
We are able to identify some genes that are important to, in the sense of understanding what makes protein so less digestible when it's wet cooked, but also in the mutants that have high digestibility, what makes them high digestible. So we're able to identify those, and also we make available to breeders these markers that can be used in their breeding program in order to accelerate their early selection of plants that have the desirable traits that they are looking for in terms of protein digestibility and nutrient content in general. When it comes to the impact that has in Senegal, we were able to develop sorghum lines that have improved post-cooking nutrient content that is more available. And as I mentioned earlier, that this is a major problem in sorghum, so being able to develop that and making it to the point that it will be available to the farmers very soon.
Sorghum is oftentimes called the camel crop. It's the crop that doesn't require a lot of water. It's able to slow and steady, adapt to changing environments, adapt to stressful environments. And in West Africa, oftentimes this relates to the changing monsoonal agricultural system that they work in. And so sorghum is naturally adapted to this production environment. And one of the things that's really critically important, I think, in the role of SMIL is actually thinking about technology development in the context of a crop that's already locally adapted to the region, and deploying these technologies into varieties that farmers already are familiar with, that are used to working with. In many cases, the variety that is improved is the variety that the farmer is already growing. And so actually developing technologies, testing them out, prototyping them in a farmer accepted variety context is a really important part of what we do. And because of that, these crops are already resilient to climate change, they're already drought tolerant. I think that's one of the really important take-home points of the SMIL program is improving crops that are locally adapted and adapted to climate change and variability. And that's really what improves their resilience.
I would just thank SMIL for the continuous support. It's not just the support started with my PhD being funded, so just as a random student. Now it has reached a point where I have collaborators. I am doing research that is having an impact to the community. So I am really thankful for SMIL for that opportunity and for the trust that was given to me by also the professors that selected me to be part of their team, and still training me to reach that level where I want to be as a scientist